Hello everyone. Today, I'll be presenting our research proposal about how personalized, emotionally adaptive AI instruction can influence children's cognitive development in early mathematics. AI use in schools is increasing rapidly, but we still know very little about how these systems affect children's learning and development. Teachers and school boards are gradually integrating AI tools, yet the research hasn't kept up, especially when it comes to how AI influences cognitive growth, emotional engagement, or long-term learning outcomes. Our project aims to address this gap by testing whether an emotionally adaptive, math-focused LLM, or large language model, can help children learn fractions more effectively than traditional teaching. Previous work on adaptive instruction shows that personalized feedback can significantly support children's learning. Studies on AI tutoring systems also suggest they can improve engagement, memory, and emotional regulation. Another issue is that current AI systems struggle to respond to the full range of children's emotions, like frustration or boredom, even though these emotional states have a major influence on how children learn. Research from Keen also shows that children's motor behaviors such as hesitation and pacing can reveal important details about how they think through problems, something AI can potentially use to adapt their learning in real time. Despite growing interest in AI tutoring, there's no research directly comparing emotionally adaptive LLM instruction to traditional teaching for early math concepts like fraction addition and subtraction. We also lack studies that examine real-time emotional adaptivity, how AI reacts when a child becomes confused, frustrated, or disengaged. This gap becomes especially important because these emotional states can dramatically influence learning outcomes and persistence. Our project combines psychology and computer science to test whether an emotionally adaptive AI tutor can improve children's math learning more than traditional instruction. We focus on 7-year-olds because this age group is rarely studied in AI education research, yet represents a crucial stage of cognitive development where foundational reasoning skills are rapidly emerging. Our hypothesis is that children who learn through the emotionally adaptive LLM will show significantly greater improvement over 6 months compared to children in teacher-led classrooms. For our methodology, we propose a 6-month longitudinal experiment with 207-year-olds, randomly assigned to either AI-based instruction or traditional teacher instruction. Both groups will learn from the same material, but the AI group interacts with a fine-tuned version of Gemini 2.5 Pro. We will fine-tune the model using examples of grade-level fraction problems, clear step-by-step explanations, and common mistakes that kids tend to make. We will also add interaction samples labeled with emotions like frustration, confusion, and confidence, so the AI can learn to recognize how a child is feeling and respond appropriately. The AI adjusts its learning using response times, error patterns, hesitation, and emotional cues detected from speech. For our procedure, students will complete 30-minute sessions 3 times a week. Both groups complete baseline tests, monthly assessments, and a final standardized test. In the AI group, teachers supervising the sessions record additional observations to confirm the AI's emotions prediction. The 6-month design allows us to capture genuine cognitive development rather than short-term boosts. Fractions are ideal for this type of study because they represent early reasoning skills and reveal consistent misconceptions that adaptive AI can respond to. Emotion-responsive adaptivity is central to the design. Prior studies show that emotionally attuned AI can increase engagement and support executive functions. We expect our adaptive system to reduce frustration, increase persistence, and promote deeper conceptual understanding, not just memorized procedures. This work also advances research on emotion-aware AI in education by giving us long-term data, not just short interactions. Overall, our project shows that emotionally adaptive AI has the potential to strengthen children's mathematical understanding and problem-solving skills. A key insight is that emotions like frustration, confusion, and confidence plays a major role in learning, and AI can help support these emotional dimensions in real time. At the same time, we recognize important limitations. Our findings apply only to 7-year-olds learning fractions over 6 months, and issues like equity, privacy, and over-reliance on AI still needs careful attention. AI won't replace teachers, but when designed thoughtfully, it can complement classroom instruction and create more personalized, emotionally supportive learning experiences. Our work provides a foundation for future research, multi-year studies, and policy decisions about how AI could be integrated into early education. Thank you for listening.